Hi there, my name is John Stevenson. I'm a host for today. So thanks for joining us. This is the second drought update that we've provided. The first one was back in late February, and it was an update on how the conditions had progressed since the beginning of the water year. And things have changed a little bit since then, but we really wanted to give you a sense for what those changes have looked like and how we're set up going into essentially the water use season. So on logistics, again, enable your speakers. The second is you do not have the ability to talk to us, but if you have questions, feel free to just type them in to the dialog box right there, the chat box at the left of your screen, and really at any point and any of the presentations, and we'll touch base on those at the end of the presentations. And I think that's about it on logistics. Again, my name is John Stevenson. I'm an extension specialist with the Climate Impacts Research Consortium. We are a NOAA-funded research group based at Oregon State, but really with researchers throughout the Northwest and the universities in Idaho, Oregon, and Washington. So this webinar is being held in partnership, though, with the Oregon Climate Service. And the agenda for today is we're going to get an update on how the water year has progressed from Kathie Dello with the Oregon Climate Service and with CIRC. And then we're going to hear from Julie Koeberle from NRCS, who's going to provide an update on the snowpack conditions for the basins in Oregon. And then that'll be followed by a presentation or an update from Bart Nijssen from University of Washington on the Pacific Northwest drought monitoring system that they've developed up there. And then Bart is also a PI with CIRC. And then at the very end, we should have probably 10-15 minutes for questions, but I would ask that once we get past that, people stay on the webinar, and we have a short evaluation that we would ask that you fill out. It's only about 5 questions. It's very helpful for us in making sure that we're delivering the right kind of information and possibly opportunities for improving next time. So please do fill that out towards the end, and I'll go ahead and send a reminder. And so with that, we'll hand it over to Kathie. And
thanks. Great. Thank you, John, and thank you, everybody, for joining us today. We're now 6 months into the water year, which starts on October 1, and we've been watching this really interesting season evolve, and April 1 is an important date for many things, especially our snowpack, which I'll let Julie talk much more about. But we just wanted to give you an update on the conditions, especially since the last 2 months have not looked like the first 4 months of the water year. And right up front, the U.S. Drought Monitor from the last week is the punchline to this whole story, this whole webinar. There's a lot of thought, a lot of data, and a lot of impacts that go into this. Our office helps coordinate it, but there are a lot of experts looking at what's going on in Oregon. How do we look in terms of drought? Are there actual things that we can measure? Are there people being impacted? And pretty much the poster child for this drought so far has been the Mount Ashland ski area, which couldn't open this year because they didn't have enough snow. You need snow to ski. We're not skiing on water. But as we've been taking in all these impacts, we've been providing inputs to this U.S. Drought Monitor and ranking the drought as going anywhere from abnormally dry, which is that D0 yellow area up in Northeast Oregon, through moderate drought, which a good portion of the state is under, and then severe drought, that orange area along the southern Oregon border. And a lot of what you'll hear about today is the southern Oregon area. It's the part that has the lowest snowpack, didn't get the conditions that they need in the winter to have a good summer. So we'll focus mostly in on that area. And it's worth noting that the D2 area, once you're under that for about 8 weeks in the growing season, you get a chance to free up some federal funds in those counties. And the 4 of those counties, Klamath, Lake, Harney, and Malheur, all have official drought declarations from the governor, and the Drought Council yesterday recommended that Jackson, which is right next to Klamath, also get a drought declaration. And I noted that the last 2 months have been almost exceptional. It's been really difficult to talk to people about drought because we saw 2 way above average months in terms of precipitation. The next few figures that you'll see are from a drought monitoring system at the Western Regional Climate Center. And one of our CIRC PIs has contributed quite substantially to this. But what it does is it ranks every month, and if those months are, here it's a 2-month span, have been wetter than normal or drier than normal, it'll show up as green or red or so on. And for the past 2 months, we've had these way above average months in terms of precipitation. Unfortunately, most of it fell as rain in Southern Oregon, which I'll again let Julie talk mostly about, but it did help things out a bit. It also underscores how dry the start to the water year was because it didn't really save us. We still have some concerns going into the growing season and into the summer. And I just wanted to step back and look at how the water years evolved. There are 2 maps here. Again, this is a percentile ranking like the last one. The one on the left is October to January. It was the 3rd driest start to the water year on record here in Oregon. That green blurb over Wheeler County, I think, is actually based on bad data, so ignore that. But it was record driest start at many places around Oregon and definitely into California, and much below normal, either 2nd or 3rd driest start to the water year. So we were hoping we'd get lots of precipitation, have a wet end of the winter, wet spring, and we did see some of that. October to March helped improve things a bit, although there are parts of Oregon that are still much below normal, and notably the Oregon coast is seeing some pretty large deficits, and I'll show a map a little bit later. So we were saying at the end of February, we really need a miracle. We need some really big months to get out of this, and we still need a few big months, and every day that ticks by, the probability goes down. But we focus a lot on precipitation when we're talking about drought, what hasn't fallen from the sky, but temperature is actually playing a big role in this as well. We did see some big storms in February and March, but unfortunately they were too warm to have snow accumulate, especially in Southern Oregon, except for at the very end of March. I'm stealing Julie's thunder here, but I'm just trying to set it up that temperature played a really big role in why we didn't get the snowpack that we were supposed to this year. And we see the bigger anomalies in Southern Oregon, which I said is experiencing the worst conditions right now. And temperature hasn't exactly looked like precipitation. The higher elevations have been warmer than normal, so again, that's not good for our snowpack. And we saw cooler than normal conditions in our lower elevations. That's a function of being under this ridge. We were either socked in an inversion in the Willamette Valley, or we had those clear nights. We certainly saw some cold temperatures. So we needed the cold temperatures up in the mountain to act as a freezer to keep that snow, but it just didn't happen. And I rarely like to talk about precipitation in terms of deficits with inches because it's really tough to visualize that, except I thought this graphic was pretty compelling. It's from the Western Regional Climate Center. And we're seeing deficits of close to 2 feet on the southwest Oregon coast. And I was recently told that Oregon is one of the largest cranberry producing states in the country, and we don't think of the coast as a drought area, but they're also seeing some pretty large deficits. Going forward, we don't have a lot of good news, and seasonal climate prediction is a really difficult time period for which we forecast. We're really good, at 5 to 7 days, but when we start to talk about the next 3 months, it starts to get a little bit dicey. So the National Oceanic and Atmospheric Administration, their weather service, or the Climate Prediction Center, puts out these outlooks, and they divide above, below normal, and just average conditions into 3 bins. So you have a 33% chance of each if there's no color. They'll tilt the odds in one direction or another if they see some sort of indication with sea surface temperatures or atmospheric patterns to do that. So the left figure is temperature probability, and the right figure, I'm sorry, it's getting cut off a little bit, is precipitation probability. So the red colors mean an above average chance of above average temperatures, and the brown colors mean an above average chance of below average precipitation. So that's bad news for the next 3 months if we're talking about needing another big month or two to get out of this. But again, it's just tilting the odds a little bit. It's not an official forecast. And going forward into summer, when we're starting to think about ag water demand and fire season, the 3-month outlook for summer actually looks a little bit worse. Again, they divide it up into those 3 bins, but they're going with a little bit stronger chance of above average temperatures in the summer. If you think back to the last 2 years, they were 2 very warm summers, and last year was certainly a very big fire year. They are going with equal chances in terms of summer precipitation. If you've spent any time here in the summer in Oregon, you know we don't typically get that much precipitation, and it won't be enough to pull us out of those deficits of a foot or higher. But really anything goes in terms of precipitation for the summer. I wanted to just give a shout out to this West-wide drought tracker system where I pulled a lot of the figures. This is what I look at almost every day. And if you're interested in the Western US and how precip and temperature and other drought indices are shaping up, certainly visit this website. And sometimes we disagree with some of the things that come out. NOAA put out a monthly drought outlook, and we don't necessarily think, after I've told you the precip deficits are so large, we didn't build the snowpack, the temperatures were too warm. They have Western Oregon with drought removal likely, and I'm not sure that we contributed to this assessment because all the indicators are pointing toward this warm, dry conditions going forward and just these very large deficits that we can't overcome. So with the exception of Northeast Oregon, much of Oregon is in a deficit moving into the growing season. We try to get information out as clearly and quickly as possible. We've been using Twitter. There are 2 of these that you can focus on. One is the Oregon Climate Service Twitter, and one is the Pacific Northwest Climate Twitter, which is the CIRC group. And a little secret, a lot of us are working on both of these, so you may see some of the same info, but it's a great way to connect with us and a great way to keep up to date. And with that, I'll turn it over to the next 2 presenters, but the summary is that despite this very wet February and March, and it's very difficult for us to grasp in these wet parts of Oregon, precipitation deficits still remain across the state. We've seen warmer than average temperatures for most of the last 6 months, especially in southern Oregon, where we needed cold temperatures in the mountains. And the odds going forward, we're thinking warmer and drier, but again, seasonal forecasts are very tough, and we don't anticipate much improvement going into the summer. So with that, we'll put Julie on.
But yeah, Julie, let's go ahead and start with you. Looks like you're all queued up, and we'll get going.
Okay, thank you. Outline of what we'll be talking about. So I'll just kind of go over quickly the seasonal snow recap and over the April 1 snowpack conditions, which we base our stream flow forecasts on. And then February, March precipitation, water year total precipitation, and a little bit of overlap there. Kathie did a good job of summarizing, and so I'll just add a little bit to that. And then we'll spend a little more time on reviewing the conditions in the driest of the basins, the Rogue, Umpqua, Klamath, Lake County, Harney, and Owyhee and Malheur. And if there's other questions about other basins, we can cover that if that comes up. And then we'll just talk about our summer stream flow forecast and our outlook report that we are looking for this summer. So with that, just quickly, I'll just talk about the February 1st snowpack conditions. It was really grim, almost for the entire state, and Northeast Oregon was still below normal. So we were starting to we were pretty concerned at that point about the shape of our snowpack for the season. And then February was really wet. So March improved the snowpack quite a bit, in some cases up to 30%. But Southern Oregon, like Kathie mentioned, while there was some snowpack improvement, a lot of that precipitation still fell as rain at really warm temperatures. So some of the higher elevation sites managed to get some snow and some rainfall, but still overall improvement, just not enough, even though the precipitation was above average for the month. And then moving along to the 1st of April, we kind of got a mixed bag. We got some improvement in snowpack. We got a lot of rainfall, with above average precipitation for the month. Some areas got an improvement in snowpacks, others some rain and some improvement in snowpack, and then there was the first round of snowmelt in the middle part of the month. And then the end of the month brought return of winter, and a lot of areas picked up some snow, but still really below normal for most of the state except Northeast Oregon for this time of year. So just kind of comparing the two side by side, March 1st to April 1st, and I kind of already said this, but some of the areas improved, others declined because they got more rain during the month than snow. Some snowmelt began. And really, there's just extremely variable snowpack conditions. That summarizes the scenario the best, because we have record low snowpacks in Southern Oregon in places, and then in Northeast Oregon, there's 2 sites that have the 3rd highest snow on record. And then within the basins, there's a lot of variability. And, you know, right now we're kind of approaching, we're pretty much at the peak of what we think of the normal snow accumulation season, and we're headed on into snow melt season. So a lot of the percents of normal actually look inflated, but in most areas, the peaks before the maximum accumulation fell well short of what they usually get before snow melt starts. So we start talking about more percents of peak snowpack this time of year than we do on the percents of normal. And we'll talk a little bit more about that when we go into the individual basins. And then I know I'm not talking really about reservoirs, but at least some of the rainy areas had some increase in reservoir storage throughout the state. So that's going to help water users that have access to reservoir storage. In some cases, it didn't improve it much, and there was about a 5 to 30% increase in some of the major reservoirs. But in other cases, that's not enough. That's a drop in the bucket, basically. So, and because there was more rain than snow overall for the month of March, there was a 10 to 15% increase in the water year precipitation totals. And so moving on to just precipitation and talking about the February and March, I know these graphics, the top, it says March 1st and the other one says April 1st, but the March 1st one is actually February precipitation. April 1st is March precipitation. So both months statewide greater than 130% of average precipitation, which is great. February overall was mostly snowpack or snow increases, except Southern Oregon. I mean, they had an increase in snow, but there was a lot of rainfall. And then in March, in general, it was mostly rain that came, except at the high elevations, and except during the last week of the month when we had a return of winter, and a lot of areas really improved the snowpack, but still not enough to even come close to normal in most cases. Some snowmelt happened during the month of March, and then they regained snow. So that's why it's kind of hard to show particularly snowpack improvement between the month of March, because there's so many other dynamics going on in the snowpack. But with that, there was so much rain on the low elevation snow. Both the rain and snowmelt was causing some short-term flooding across areas of the state. And here we are talking about long-term drought. But basically, and Kathie had said this well too, but 2 wet months just really can't undo the damage done from the dry October through January, when we're used to getting so much snow accumulation in December and January especially. So then that makes the water year precipitation totals look relatively good, in a lot of cases near normal, almost for northern part of the state and parts of the Willamette and Central Oregon, but otherwise below normal for the water year. But while that looks good, we're still talking about water shortages. Again, just 2 wet months can't really turn around the effects of the low snowpack. So with that, we'll just kind of move on to the individual basins that we were talking about that were the driest. And I'll start with the Rogue and Umpqua. And as of today, the snowpack is 35% of normal. And the peak of the snowpack for most areas, we did about a standard deviation, one standard deviation, and then rounded kind of to make it, because it was all over the board. Like I said, it was very variable snowpack, but in general, 20 to 40% of the average peaks, so well below what they usually get before it starts to melt. And I have the little box that says hit the hardest. Basically, southern part of the basin along the California border and northern California part of these contributions to these rivers really just were hit the hardest. We had record low snowpacks, and like Kathie mentioned, Mount Island ski area never did open, and then areas below 5,200 feet just really didn't get a snowpack this year. And so if we move over to the next slide, you'll see that this is kind of our snowpack index, and the black dash line is the normal, and the red line is the current year. So I just kind of mentioned here that February precipitation was above average, and there was some snow. You can see it in the red line. There was an improvement in snowpack, and then in March, you can see March to April. I mean, there's not really much improvement. It's sort of just flatlined, and there was some snow melt in there and some rain until the last week of the month. You can see kind of the snowpack kind of just barely getting out of record lows. So there was, all kinds of just bizarre things going on in the snow this year for this area. And we have also on this graph some other dry years, 81, 90, 91, 92, and 2001. And, at some point in the year, they were similarly low. And then, it just illustrates really the wide range of outcomes that you can get early in the season when we are expecting dry conditions. It can anything can happen. Once we start moving over to the melt season, then it's impossible for us to really get back to normal at this point if you look at the normal median line. And then you can see that giant deficit where the red line, and I have a little red arrow pointing to the normal peak, so the peaks were 20 to 40% below that. So pretty grim situation. And then this snow-tail site, Big Red Mountain, was a record low this year. And then this has just potential outcomes of how the snow can evolve from this point on, the purple being the max, and then the kind of brown line is just plummeting down, probably somewhere near the bottom of that graph, I'm guessing, if it stays as warm and dry as the outlook looks. But something interesting about this site is on the 26th of March, the snow depth, there was a foot of snow basically, and on April 2nd, there was 27 inches of snow on the ground, so basically more snow depth. There was more snow that fell during this time than was on the ground all winter in snow depth. It's not the case for the water content stored in the snow, but it is the case for the amount on the ground, which is quite interesting. And then the next site, Bigelow Camp, this just illustrates they didn't get a snowpack at those lower elevations that usually do, and you can see the dash line where that's the normal amount. So just didn't happen this year. Very unusual. And so moving on to the Klamath Basin, today's snowpack 30% of normal, and the peaks were only 10 to 40% of their average annual amount. And again, those sites that are kind of over on the eastern side of the basin, especially the ones close to their Oregon-California border, did the worst, and the ones that are up near Crater Lake did a little bit better, the higher elevations. But overall, just really poor snowpack this year. Similar situation where below, around 5,000 feet and below, just didn't get a snowpack. In the February, mostly there was snow. Precipitation was 100 and almost 80% of average, but there wasn't. It just needed a lot more. It wasn't enough. There was a lot of rain that had fallen too. And March was 155% of average precipitation, but there was a lot of rain. And there was some snow. You can see that red line kind of jumping up here and there. But, you know, it's really characterized by snow melt and rain until that last week of the month where it had, you know, A for effort. But it's just not good enough. It's going to be, you know, a really dry year and only 10 to 40% of normal for the peaks. And you know, we put those same years, 81, 90, 91, and 92, and 2001, just so you could kind of see. Those were also some low years, but just, you know, there was a lot of variability around the 1st of February and 1st of March of what could happen in the season. So that's moving on, I guess, with that. We'll go on to Lake County and the Goose Lake Basins, Oregon's closed basins. Similar story. You can see that red line for large majority of the season is setting a new record lows in the white space. So lowest snowpacks on record. April 9th snow was 43% of normal. But again, that sounds better than it is because the peaks were only 10 to 50% of normal. And you can see how that red line is getting closer to the normal melt curve. So that's why we don't generally like to focus on percents of normal too much at this stage in the game. But again, you know, February and March were wet, but there was a round of snow melt that we didn't like to see, and it tried to come back at the end of March with some snow, but just can't undo the damage. And then the Harney Basin today, 66% of normal snowpack, and the peaks are about 40 to 70% of the normal amount. Again, above average precipitation, it's kind of the same story for each of these low basins, really, where, you know, February was snowier and March was wet, but it was more rainy, and then warm temperatures instigated the first round of snow melt, and then a boost in snowpack there towards the end, but still 40 to 70% of that normal peak amount. And Owyhee, Malheur today, 68% of normal snowpack today for Owyhee and 63% for Malheur. And you can see up in the kind of the Blue Mountain Spring, Lake Creek, and Rock Spring, there's only 3 sites that we have there in the Malheur. So we generally group them together so we can get more information. And the water equivalent snowpack peaked about 40 to 80% below the normal amount that they get before melting. Again, above average precipitation for both months. February brought snow, March brought little snow, some rain and snow melt, and a boost at the end. But still just fell really short of that peak. And this graph really highlights that. You can see the red line really approaching the melt curve, so it makes it look like the percent of normal looks better than it is, but it's kind of not the best thing to look at this time of year. And so that brings us to our stream flow forecast. Really, they mirror where the snowpack was, you know, where they're really below normal, extremely dry. Summer stream flow is expected is where we just didn't really get that snowpack. That's our frozen reservoir storage that we know we can count on. Spring rains would be helpful, and they'll help offset irrigation demand and wet up the soils. But we can't rely on it, especially when Kathie shows that forecast for the long range looks hot and dry for the summer. Can't rule out a storm or two here in the next couple of months, but it looks like the general trend is leaning towards drier. So just don't have a crystal ball, but at least with snowpack we know what we got, and this year just we didn't get it. And so those southern basins along the California border and then parts of central Oregon and southeastern Oregon are just really looking like they're going to be in pretty bad shape. below 50% of normal stream flows for the summertime. So with that, I think that's really all I have.
All right, so basically as the third speaker in a three-speaker lineup, I'm not suddenly going to tell you something entirely different from what the other two speakers have already told you. But I wanted to give an update kind of from the presentation I gave in late February, and also provide a little bit more of a regional perspective to what we've seen so far. So next slide, please. So basically, this is what we showed in February, and we basically, late February, and basically almost the entire Columbia River Basin was in fairly severe drought, except maybe the Rockies and the entire eastern edge of the domain. There's also kind of a red spot in the Columbia River Basin in this case, in the Canadian part of the Columbia River Basin. We've got to figure out that that's actually more to do with a few or a single low elevation station that's kind of giving us an anomaly up in that region. But basically the state at the time was that there was severe drought in eastern Washington and all of Oregon and in southeastern Idaho. But also the coastal part of Washington State was pretty dry. Next slide, please. So since then, so this is basically the same thing, but from 2 days ago. Basically, the moisture conditions in the basin have much improved. And just to kind of briefly recap how we make these images, we basically take the same meteorological information that was presented by the two previous presenters, and we run that through a hydrological model, and we do that on a daily basis. And then we basically report the fields that we get out of these model simulations and compare them to similar dates in the past. So basically, when we say percentile here at the bottom, when it says the 10th percentile, that means that 90% of the previous April 7th were wetter than this, and 10 of them were drier, or 10% were drier. So basically, when you see these very dark red colors, that basically means that it's almost the driest on record. And we know actually that that's not quite true in Canada, as we can show later in some snow plots. But one of the important differences between the previous slide is now that we actually have some areas in upper Idaho and in Montana that are actually slightly above average. And also the colors in Oregon are much less towards the dark reds or the reds and much more towards the light browns and the whites. Next slide, please. So these are also slides that we provide on our website, and this is basically what I showed in the end of February. Basically, this is SNOTEL sites over the entire West, plus some state of California sites. And again, it's shown as a, in this case, actually as a percent of normal. And so, yellow basically means that the sites are between 70 and 130% of normal. Reds are that they're much drier than normal, and blues are that they're much wetter. And what you can see during February is basically a shift from reds and yellows to still a lot of reds and yellow, but more towards yellows and even blues on the eastern edge of the Columbia River Basin. The reds in Oregon actually became a little bit lighter, although in western Oregon they still remained red. We're still well below normal. In Washington, along the Cascades, the colors actually during February went from red to yellow. And if you go to the next slide, which shows current conditions, you can actually see that in Washington State, snowpack along the Cascades has largely recovered. There's this pretty sharp break once you get to southern Washington into the reds, and although they're not as red as they used to be, they remain red. California is kind of an extreme version of what's happening in Oregon. Their snowpacks are well below normal and have remained below normal. On the eastern edge along the Rockies, we actually have some above average snowpacks in Montana and in Idaho and Wyoming. These are actually observations. These are not models. Next slide. So these are actually modeled fields. And if we actually look, this agrees very well with what the previous speaker said. in February, which is the left plot, we actually show a big shift in the percentiles of the snowpack, meaning that the snowpack, rather than being well, basically we got more snowpack than we normally would during that period of time. In March, the snowpack has largely remained unchanged, even though we had significant amounts of precipitation, but temperatures were fairly warm, and so a lot of that fell as rainfall, even at higher elevations. Next slide. So on our website, we also give time series kind of aggregated over sub-basins, and you can actually go online and actually explore this yourself and click on it. But again, on the left side is what it looked like by sub-basin at the end of February, and the right side looks at shows what it looks like currently. And we see the same thing, kind of the colors are less red, and these are again model results from our model, which in this case is big. There was a question about that. So we still have kind of drought conditions throughout much of the basin. I think, as I said before, that the Canadian red spots that we show are anomalous and actually are a problem within our own system, which is kind of a research system. And one thing that it actually makes the case for is doing data simulation, actually assimilating the snow as observations that I showed earlier into our model simulations, which is not currently done. In Oregon itself, you can see that much of the reds have disappeared. So the reds was basically the 2 to 5th percentile, or a 1 in 20 to 1 in 40, 1 in 50 year event. Is now more like browns and yellows and so on. So it's much less extreme than it was, but it's still a drought situation. Next slide, please. So, as I said, you can actually click on each of these sub-basins and you will kind of get a time history for the current water year, plus a little bit extra into the past. So these start actually at August 1 of the last year. You can kind of get a time series, and it looks very much like the snow plots that Julie just showed. We basically compare it with past conditions. The inner dark gray is the 25 to 75 percentile, and the light gray is a kind of the 0 to 100%. And so what it kind of shows is that we did have, for some of these basins, this, for example, is the lower Deschutes, that there was a big bump up in the snowpack in February, but since then the snow hasn't really changed a whole lot, even though, as Julie showed, there's been quite a bit of precipitation. You can kind of see that both snow water equivalent, bottom left of the panels, and total moisture, which is snow water equivalent plus snow moisture, soil moisture, have recovered quite a bit, but still remain around the 25th percentile. Next plot. So this is for the upper Klamath, and there you can see that soil moisture there has increased quite a bit from February through current, with again much of that change coming through February and the first part of March. The snow water equivalent is much below normal, and we're basically going around the maybe what's the 10th percentile and so on. And since that's what gives much of the moisture later on in the season for runoff, runoff projections for all these basins still remain fairly low if we look at the April through July volume. So the next slide basically shows the locations for which we're providing April through July volume forecasts at the moment. And again, the colors here basically show the percentiles. The red dot in the northern part of the basin is again slightly anomalous, and I'll come back to that. But the ones in Oregon, you can see they're basically reds and yellows. And we'll look at some of these locations in a little bit more detail. Next slide, please. So these are our volume forecasts for the dials. And in the left side of the plot, it basically shows the date on which the forecast was made. And every single time we're forecasting the same April through July volume. So the leftmost box plot was the forecast made on February 5th, and the next one, the one on February 12th, and so on. The red line shows the median of the forecast. The dot shows the average of the forecast. And the box itself is the 25th to the 75th percentile. So as you can see, actually the forecast, oh, and so this is for the dolls. The left plot, as I said, is percentile. The right plot is actually percent of normal. So for the left plot, a normal case would be the 50th percentile, meaning that 50% of the years are wetter, 50% are drier. The right plot, the normal line would be at 100%, right? So percent of normal. So that's why these are slightly different. Basically, in the left one, if you have a dot at 20%, that's a 1 in 5 year event. Okay. So as you can see, the forecast for the dolls actually have recovered quite a bit, although we remain kind of at 40th percentile, or about, in our case, probably 90% of normal. We're slightly lower than the RFC at the moment, which I think is mostly due to this anomaly or this problem with our forecast system that we're having over the Canadian part of the basin, which actually doesn't show any great anomaly in snow accumulation. Next slide. This is the forecast for the Willamette River at Portland. Again, there's been a fairly big increase in the forecasted amount from the beginning of February through the end of February, and since then the kind of forecast has gone up and down a little bit, but hasn't changed a whole lot. The RFC makes the same forecast as we do, of about 81% of normal. We're kind of in that same range currently. Next slide, please. This one is the Deschutes at Moody. And of course, you know, as we showed earlier, parts of Oregon remain much drier than others. And so for the Deschutes, even though the forecast has gone up and then kind of bounced around a little bit, we're still talking about a 1 in 5 year event or so, with the average flows being forecasted in about the 70% of normal range. And next one. And this is the Klamath. I mean, the Klamath kind of, even though the forecast went up a little bit in February, hasn't budged a whole lot in the total amount. And just like Julie was saying in the last presentation, our system as well shows that the likely forecast is for about 50% of normal in the April to July volume forecast. Next slide. So one thing that we actually did over the last month is to extend our system to include California, because a lot of the eyes right now are on water resources in California. So Mu Xiao, the graduate student who's working on this project, basically expanded the entire system to include California. And as you can see, although there's been some relief in California as well, much of California remains severely problematic. Next slide, please. These are the same plots, but this is the volume forecast for the Sacramento River. And, it kind of looks like the Klamath. The likely forecast is for about 50% of normal, and maybe a 1 in 7, 1 in 10 year event or so is what we're talking about. Next slide. We kind of went back into our system, which actually kind of, to put the current conditions into a historic perspective, we actually run back and we have a complete model simulation using the VIC model all the way from the 1920s to current. And this is basically looking at the March 23rd snowpack in California for this whole period. And as you can see, like, this is the last 2 years on this record are very low compared to the past, and the current one might be one of the lowest ones on record. They have seen similar ones in the past. In the 70s, they also had a severe drought, and this one in many ways looks very much like that one. And kind of that's the last piece of my presentation. So.
Okay. Well, Bart, thank you very much. And thanks to everybody for participating. I do want to note that we've been recording this, and we will try to post this on our website in a reasonable time frame. Obviously, it's has a shelf life when it'll be out of date, but we will try to get that up and then notify you for those of you who registered. If you do have other questions, feel free to contact the speakers directly, or you can contact Kathie Dello or myself, and we can forward those questions on. My email address I will put in right here.